Next, I want to talk through just a few case studies, again, of some work that we've done here at HiMed. So this is an image of node post-processing. I don't need to beat the dead horse on the beads existing. They were there. And we ended up taking some of these 3D printed lattices and aluminum oxide blasting it. That's a common grit blast media that's used. And when we did blast, we see that it does effectively remove those residual beads. However, we see embedded contaminant remains on the implant surface. So all those darker areas there, the dark gray, that's aluminum oxide still embedded in the surface of the part itself. But using something like Matrix MCD, our proprietary apatitic calcium phosphate abrasive, you end up having a biocompatible post-processing, producing a clean and contaminant-free surface following passivation. So you get your micro-texturing and things like that, and you get rid of those residual beads, but you don't have any embedded particles and no aluminum oxide, obviously, in your process. This was just a little bit of fun we had in Python a couple of months back. So customer had sent us some parts that we treated, and they had sent us a few parts that were aluminum oxide treated in terms of the blasting. And we wanted to figure out, how do you quantify what percentage of your surface is no longer your osteoconductive titanium alloy? What percentage of your part is now covered in aluminum oxide? And so we did some histogram-based and adaptive thresholding, and then you can plot out the pixel intensities based on the images themselves to say, how much dark spots am I seeing on the aluminum oxide as compared to the Matrix MCD treated surface, where you then passivate and remove the calcium phosphate, leaving the pure titanium alloy. So I think this next slide shows it a little bit better, where up to 10% of the surface, it depends on where you put your thresholding, but you can kind of see on the right with the red graph of the aluminum oxide blasted part, you almost had a bimodal distribution where you have a larger cluster in that lower pixel intensity, and that's all the aluminum oxide being the dark spots in your image, as compared to over on the right side, that's your titanium alloy. As compared to the blue, with the MCD, you have a single crisp peak, and that is your MCD treated titanium alloy that you have left over. So it depends on where you put your thresholding, but anywhere from 5 to 10% of the surface, at least in the samples we've seen in-house here at HiMed, is really aluminum oxide. It would be glass beads. It would be other materials that are not able to be dissolved afterwards, such as something like Matrix MCD.